All right, today we're diving into something you use every single second you're awake, but probably don't think much about. We're talking about the human eye. I mean, it seems so simple, right? You just open your eyes and you see. But the engineering packed into that tiny little ball, it's absolutely mind-blowing. So let's start with a really basic question. How do you know anything about the world around you? I mean, really, how do you perceive it all? Well, the answer is, of course, our senses. They're like these incredible biological bridges connecting your inner world, your brain, to everything happening out there.
You've got your 5 special senses, right? Vision, hearing, smell, taste, touch. But let's be honest, for most of us, sight is the MVP. It's our go-to for figuring out what's what. So that's what we're going to do today. We're going to peel back the layers of the amazing little machine that makes it all possible.
Okay, let's start our tour. We're going to tackle this from the outside in, starting with the eyeball's basic structure and its protective shell. So first things first, the eyeball itself is tiny. Just think about it. It's an almost perfect sphere, only about 2.5 centimeters across. That's about the size of a gumball. And yet, it's crammed with some of the most intricate and complex tissue in your entire body. It's wild. Now, to wrap your head around its structure, the easiest way is to think of it like an onion. Seriously. It's built in 3 main layers, one inside the other. You've got the tough outer layer, called the fibrous coat. Then the middle one, the vascular coat, which is full of blood vessels. And finally, the inner nervous coat. For this explainer, we're going to focus on those first 2 layers to really get a handle on how this thing is built and how it does its job.
All right, let's zoom in on that first layer, the protective shell, the fibrous coat. It's actually made of 2 very different but equally important parts. You've got the white part of your eye, and then you've got that clear window right at the front.
Most of that outer shell is something called the sclera. That's the tough, white, opaque stuff you actually see when you look in the mirror. Its job is super important but pretty straightforward. It protects everything delicate inside and keeps the eyeball in that nice, strong, spherical shape. It's literally the eye's armor. And get this, it covers almost the entire eyeball, a full 5/6 of it, which naturally leads to the question, okay, so what's up with that last 1/6? Well, that front 1/6 is the cornea. And this is where things get really cool, because it shows you how perfectly structure is designed for function. The sclera is white, opaque, and tough for protection. The cornea, on the other hand, is perfectly transparent. And it has to be, right? It's the window. It's the only way for light to get in. So you have 2 parts of the same outer layer doing completely opposite things.
But that perfect transparency is pretty special. And the secret to how the cornea pulls it off? Well, it's not about what's in it. It's about what's missing.
And here it is. The cornea is avascular. What does that mean? It means it has 0 blood vessels. None. Just think about it for a second. If it had a web of tiny red blood vessels running through it, your vision would be a blurry mess. So this lack of blood vessels is absolutely key to how we see. And this little fact has a huge real-world consequence. Because there are no blood vessels, it's really hard for your body's immune system to get in there and attack foreign tissue. And that's exactly why corneal transplants are so incredibly successful. The body just doesn't reject the new tissue as easily. Pretty incredible, isn't it? Okay, so we've covered the outer shell. Now let's go 1 layer deeper into what I like to call the engine room, the middle layer, the vascular coat. This is where the eye gets its power supply and where the real magic of focusing happens. The big player in this middle layer is the choroid. It's this dark, pigmented layer, and it is jam-packed with blood vessels. Its whole purpose is to be the eye's lifeline, feeding nutrients and oxygen to all the other parts, especially the retina, which is super energy hungry. But the choroid isn't just a simple sheet of tissue. As it wraps around toward the front of the eye, it actually changes. It thickens up and morphs into this really powerful, ring-like structure. This structure is called the ciliary body, and you can picture it as this muscular ring that sits right behind the colored part of your eye. The key component here is the ciliary muscle. This thing is, for all intents and purposes, the eye's autofocus motor. It's working all the time without you even thinking about it to change the shape of your lens and keep everything you look at perfectly sharp. So how does that autofocus actually work? Okay, imagine you're looking at something far away, and then you glance down at your phone. In that split second, a whole chain reaction happens. First, that ciliary muscle contracts. It squeezes. That actually causes the tiny ligaments holding your lens to go slack. And when they relax, the lens, which is naturally elastic, bulges out and gets thicker. That new, curvier shape is what bends the light perfectly to focus the image of your phone onto your retina. And this happens instantly, every single time you shift your focus. It's amazing.
Okay, so we've seen some of the incredible anatomy inside. Now let's connect this to the real world. What happens when these perfectly engineered parts get damaged, or even when they're just built a little bit differently? Let's circle back to the cornea for a second, that clear window to the world. If it gets injured, it can scar, and that scarring creates cloudy spots or opacities. All of a sudden, your crystal clear window is foggy, and it starts blurring the light before it even has a chance to get inside. And it's not always about major damage. Sometimes really subtle differences in the eyeball's shape can make a huge difference. You've heard of myopia, or being short-sighted, and hypermetropia, being long-sighted, right? Well, a lot of the time, those conditions are just caused by tiny variations in the length of the eyeball from front to back. We're talking millimeters of difference in that little 2.5 centimeter sphere, and that's enough to determine whether you need glasses or not. So there you have it, a quick journey from the tough outer armor of the eye to the incredible autofocus machinery inside. The crazy part is that we use this system every single second we're awake, and it all feels so effortless. But now you know it's being powered by this unbelievably complex and precise biological machine. From a window that stays clear by having no blood vessels, to a muscle that can refocus faster than the most expensive camera, it really makes you think, doesn't it? After seeing just a little bit of what's going on in there, what's the one part of the eye's design that you find the most amazing?